So far we have studied about relations, and now we move to our next topic, functions. Now function is one of the most important concept in mathematics. The word function is derived from a Latin word which means to perform something or an operation. Functions are also very important in differential and integral calculus, which you will study later. So in this episode and the coming episodes, we shall study functions in details. So let's first define what a function is. A function is considered as a special kind of relation. Suppose we have got A and B as two non-empty sets, then a relation f from set A to set B is a subset of A cross B. And now this relation is called a function from A to B if it satisfies two conditions. First, for each element A which belongs to set A, there exists element B which belongs to set B such that the ordered pair AB belongs to function. And the second condition is if any ordered pair AB belongs to F and another ordered pair AC belongs to F, and that's possible if and only B is equal to C. Or in other words, we can say there is a function from set A to B if each element of A appears in some ordered pairs in F and no ordered pairs in F have the same first element. We can also define function as a correspondence between two sets. A function f from set A to set B is a rule or method or correspondence which associates element of set A to elements of set B in such a way that it satisfies two conditions. First, all elements of set A are associated to elements in set B. And the second, an element of set A is associated to a unique element in set B. Or we can say a function f from a set A to a set B associates each element of set A to a unique element of set B. Sometimes we also use the terms like map or mapping as a synonym for function. And if f is a function from a set A to a set B, then we can write f colon A to B. And we read it like f is a function from A to B, or f maps A to B. Now suppose we have an element A from set A, and suppose it is associated to an element B from set B, then B is called the F image of A, or simply we can say image of A under F, and we can also call it as value of the function f at A. Also, A is called as pre-image of B. Now what do we mean by domain, codomain and range of a function? Now suppose we have a function f from set A to set B, then the set A is known as the domain of f and the set B is known as the codomain of f. And now what's the range? The set of all f images of elements of A is known as the range of f. Also, the image of set A under the function f is denoted by f of A. And always remember, f of A is a subset of set B. Now let's take some example and test whether they are functions or not. So in our first example, we have got two sets, set A and set B. Here set A contains 3 elements, 2, 3 and 4, and set B contains 3 elements, 5, 6 and 7. Now a function f1 from set A to B contains 4 ordered pairs. f1 is equal to 2, 5, 2, 6, 3, 7, 4, 7. Here you can see the element 2 is related to 5 and 6. That means the element 2 has got 2 F images, 5 as well as 6. And 3 related to 7 and 4 is related to 7. Now let's check whether it satisfies all the conditions to be a function. The first condition is for each element A which belong to set A, there exists an element B which belong to set B. So here you can see all the elements in set A, 2, 3 and 4, they have got F image in set B. That means first condition is satisfied. And now let's check for second condition. And the second condition says an element of set A is associated to a unique element in set P. For this relation to be a function, 2 must relate to only one element in set B, but it is associated with 5 as well as 6. So that means this relation is not a function. Now let's take one more example. For the same set A and B, suppose we have a function f2 which consists of 2 ordered pairs 2, 5 and 3, 6. That means 2 is associated with 5 and 3 is associated with 6. Now let's check whether it satisfies all the conditions to be a function. Here you can see 4 is not associated with any element in set B. That means the element 4 in set A has got no F image in set B. Or we can say the function has no value when A is equal to 4. But remember from the definition of function, for each element A which belongs to set A, there exists an element B in set B such that the ordered pair AB belongs to function. So here this condition is not satisfied. So that means again this is not a function. Let's take one more example. Here we have a function f3 for the same set A and B. Now f3 has got 3 ordered pairs 2, 5, 3, 6 and 4, 7. Here 2 is associated with 5, 3 with 6 and 4 with 7. Now is this a function? Here you can see each element of set A is associated with some element in set B. So the first condition is satisfied. And the second condition that each element of set A must be associated with a unique element in set B, that is also satisfied. 2 is related to 5, 3 is associated with 6 and 4 with 7. So that means this relation satisfies all the condition for a relation to be a function. So this relation is a function.